Hopefully everybody has their fixture open. What we're going to do next is create the nozzle or the aerator that's attached to up over here. To do that, I am going to create a cylinder. We use the simple 3D modeling tools, which is the cylinder. I'm going to click on the screen. Now the only problem is my X and Y is facing the different direction, but that's alright. I'll just rotate it later on. For this, I'm going to use a diameter of 1 inch, and the height will be 0.25. Now you can adjust that as you wish, but that's the size I'm using. Now here's a trick. Instead of going to your move gizmo up here every time to change your gizmo from moving to scale to rotate, you can also right click once you have an object selected, and you can select it from here which one you want activated. So right now I want rotate to be activated, so I can rotate my object, and I need to have ortho active so it's perfectly 90 degree. And now I can position it by using the snap option. So I move the object from the center point and I move it to the quadrant or midpoint like so. From there I have to move it back, which again I have to change my gizmo. I change it from rotate to move, and I move it back a certain amount, maybe 1 inch, giving me my nozzle. The only problem here is, as you can see, there's this gap in between the actual fixture and the actual aerator. So I need to resolve that problem. It's either I move this aerator back, then I lose the thickness, or my other option is I use the extrude faces, which is probably my best option for this. To use the extrude faces, what you need to do is go back into your home tab. There is a option next to slice. It's usually extrude faces. If you used a different option before, it might have those setups as well active. So hit that arrow, make sure you have extrude faces. You select the top of the aerator, and we're extruding it up a distance of ½ an inch. So I'm clicking on the screen away from my part so I don't snap onto anything by accident. And I'm going up at 90 degrees at 0.5 and accept it. That extends the aerator all the way through the object, where we can now union it and become a one complete solid object. So I can use the union command, select both, and it's done. Now if you want to make it even nicer, you can also add fillets to the edges on this, and of course to any part of this whole design you can add fillets. The next step will be to make the aerator. So I want to make sure the shank. So I want to make sure everybody got this completed before we move forward to that. So the next part we're going to actually do would be the shank, which is a 1 3/8 inch and overall height. So we use the cylinder command again. Again, I have the UCX in the wrong coordinate system, but that's alright. I can still rotate it once I'm done. So this is 1.375. First D for diameter. 1.375. And our length will be, I would say, 3 inches. That will be our shank. Of course, I can rotate it to create the right kind of view of the cylinder. Once I have that, I also have to create the threading. To do the threading, I need to draw up a mock-up of what the thread cut will be like. So this is kind of what the shape will look like, except that I need to make that into the right scale. So first of all, the top piece is 0.02. I'm going to use a center line to go all the way across, which is 0.1, and then the back is 0.06, which is 0.3 both ways. I'm going to use something like this to cut into this cylinder. We might need to enlarge this, but I think we should be okay. So that was my quick preview, and then the actual dimensioned apart. I'll add the dimensions for you guys so it's not, I don't lose you anywhere. So once you have that completed, what you need to do is make a copy of it and either make this a polyline using pedit, or you can use the draw region command, which will create that piece into a region which you can actually extrude or sweep or anything. So once you have this completed part, we need to do next is create the helix that will follow around the cylinder so we can actually cut the threading. To do that, you have to go to the helix command, which is in the draw options. There is a helix. It creates both a 2D and 3D spiral. So you start out with the helix. It's going to start with the first question, or it's asking you for the helix specified center point of base. So our center point will be the center point of the cylinder. We select that, and our diameter will be the outside edge of the circle or the cylinder. And finally, our outside radius for the top is also the same. So again, you select the edge of the cylinder. Finally, you pick the direction. Usually you zoom out for that to make sure you're going in the right direction. Our turns, we specify that as well. And our turns will probably be, let me just see, 100. Might be a little too big. Actually, I'm going to try that out. I'll have to come back to this if I did that wrong. You can always go back and change it. If you're not comfortable with 100, you can go back to T for turns, and you can specify something less. I'm going to do 60. So I'm using 60 turns, and my axis endpoint, we don't have to worry about that. Turns, height, and twist, it's a factor of 1 is fine, but we do need to specify the height. The specification for the height is usually either you overextend it or you snap onto the center of the bottom of the cylinder, but I do not recommend that because it doesn't go all the way through. So just extend it a little bit over, giving you a helix that is going all the way around the cylinder and even more. Now the problem is here is we need to find out where the beginning point is of this helix, because that's what we're going to be using to revolve our new triangle shaped cutout. I'm going to change the color of my helix or ease of seeing it, and I can tell that the helix started somewhere over here. I can even see the end point where you can snap onto it. So that is the point where I want to place this cutout. So I'm going to move this over, and I'm moving it based on the back, the larger vertical line, center point. I'm moving it over to that place, and this is where I need to rotate it using the rotate gizmo to adjust it once more. So I have something like this, and I'm going to have to make one more thing with this before I start doing the, well, actually, yeah, no, that's fine. So what we're going to do next is use the sweep command. To do that, what you want to do is go into your Home tab, go to Sweep, select the object you are sweeping, which is this triangle, enter, and then to make sure you select the helix instead of the actual cylinder, just zoom out, select the helix at the bottom. I had a feeling this helix is going to be too small. So this may happen that your helix won't work with the triangle shape you have created, and here's the reason. If I create a copy of this triangle and I place it at dead center Oh, at this point it's not working too well. But usually it overlaps at a certain point. And when it does that, it hits itself and then it doesn't allow you to revolve it. So you gotta keep in mind about that. And if that's not the case, there also is the case of the alignment. So you have to make sure that you align your triangle so that it actually follows through the path and not rotates around the path. To do that, when you do the sweep command, when you select the object and then you select enter, it has an option of alignment, base point, scale, or twist. Where we set up alignment, we want to make sure that it's a no, it's not active, so it does not turn over with the helix. That causes problems. Then you select the helix and then you'll see the part being rotated all around, all the way through. Once you have that, all you have to do is save your work, because this gets usually complicated and computers can't handle this. It's the subtract command. You take subtract from the cylinder, the new helix, and you end up with a shank, threaded shank, like so. What else you can do is you can create a inner cylinder at the center. This could be tricky to grab. If you can't find a center point, you can always make one. There we go. And my circle is the wrong rotation. That's probably not good, so I have to change my UCX, making sure my Z and X face that same plane as that top of the cylinder. There we go. Do a circle at the center, and I'm going to do about 0.5 for the radius. Then I do the extrude, or I can try using press pull. Oops. Gotta delete that center line first. And that cuts out the hole for the shank. Once you have that completed, all you have to do is align this shank, which you do have a center, to the 2" by 2" rectangle or square at the bottom, and you just gotta move it 1 inch over. Since it's 2" 2" 1 inch will be the center of it. Creating your fixture. Now, if anybody wants to add the hoses to this, that's pretty simple too. What you want to do is change your UCX so it faces the front or right plane of the cylinder, so that we can draw a spline pretty much based on what you prefer, but you want to go into like a front view of the part and just create a line directly exiting. Oh, is this a line? I was supposed to use a spline. Where's my, oh, spline. Create a directly straight spline at first, and then you can start bending it around into like a wire hose shape. From there you can create a diameter of the circle you want to sweep. It does not have to connect to the line. This is the easy part. All you have to do is use the sweep, select the circle, select the path, select the circle, enter, select the path, and it just follows through. Pretty simple, it does it by itself. You don't have to worry about anything. And then just finally place it inside the shank. Just rotating it around and snapping it on, and making a copy of this one or creating a new one for the second hose for the cold water. And If you like, you can rotate it, but then you have to move it back into that same set position. Ooh. The tricky part is, since my shank is so small and my hoses are so big, I kind of create them too big, so they're going to overlap in my design. But that's just for a visual view anyways. So there's my fixture with my hoses, my shank, my handle, aerator, everything I need to show this to a client for his approval if he wants to move forward to actually creating the more detailed engineering drawings. So